Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afika binti Mustaman and this is my group members, which is Dr. Mahyuzi bin Jainal, Professor Madya IR Dr. Irwan bin Sulaiman and Syed Muhammad Naufal bin Syed Usman. So today, I would like to present our project, which is new design of H configuration modular rotor permanent magnet flux switching machine for passenger drone. So in recent years, studies have been done to the FSM and becoming well known for their benefits of having high torque, which leads to also high power density. So, flux switching machine can be divided into three categories, which is the first one is permanent magnet flux switching machine, PMFSM, which have only permanent magnet in the machine. Then the second one is field excitation flux switching machine, which is FEFSM, that have field excitation coil in the machine. And the last one is hybrid excitation flux switching machine, HAFSM, which have both permanent magnet and field excitation coil in the machine. So, with the increasing research and development with FSM have increased for the past few years, especially for PMFSM. More researchers have been focusing on the PMFSM, which have double salient yet simple design of rotor, but with complex stator configuration structure, which is almost identical to the common permanent magnet brushless motor. Moreover, permanent magnet flux switching machine also have structure construction which is similar to the switch reluctance motor. Besides, permanent magnet flux switching machine is one of the type of FSM which has the simplest construction that requires no external field circuit connection, yet it is loss-free excitation. Other than that, based on previous research, passenger drone use permanent magnet synchronous motor and induction motor to operate as personal air vehicles. There are a few advantages of passenger drone, such as traffic reduction, saving travel time, and environmental relief from the field excitation flux. As the goals are not only to enhance the productivity and cutting the cost, but to also improve the efficiency and optimum torque of the machines. So recently, research on double stator have shown significant popularity compared to the single stator. There are still research on the development of various rotor structure, especially for double stator permanent magnet flux switching machine, which only limited for a few salient or segmental structure of rotor. But there are still some drawbacks of passenger drone, which are affecting the air pollution and also the traffic. So this results to the development of this project to resolve the issues and optimization of double stator with H design modular rotor, permanent magnet flux switching machine with unique features of non-overlap winding, low copper losses, high efficiency. A smaller number of permanent magnet have been proposed. However, with the only salient rotor structure available, it has much longer flux path, which lead to much higher flux loss. As the flux loss increase, the tendency of the torque and the power density can be increased earlier, thus causing the weight of the rotor to be heavier. The flux path is not fully utilized on the iron core, as some of the area are at the stator is not fully distributed by the flux. There are three objectives to be achieved from this project, which are to propose and design a new double stator permanent magnet flux switching machine with H design modular rotor. The second one is to reduce the air pollution from vehicles and achieve near to zero emissions. And last but not least, to improve the transportation efficiencies. This is the motor that have been designed for the passenger drone. The motor have four structures, which is stator, permanent magnet, rotor, and also last but not least is armature coil. Next, this is the general flow chart upon finish this design successfully, starting from sketching until analyzing the motor. Next, for the result, the torque performance results for this design is 46.13 Nm, which are better than the other motor structure with salient rotor. Next, from the load analysis, the cogging torque for this motor is 16.12 Nm. In conclusion, double stator with H configuration modular rotor PMFSM has been designed to analyze its performance by using JMAX software. Moreover, double stator H configuration modular rotor permanent magnet flux switching machine has higher torque performance and efficiency than the developed motor, which increased by 83.84%. Lastly, for recommendation in future work, it can be used ALSURAF as permanent magnet because ALSURAF can help to reduce the flux cancellation due to the opposite flux produced by the radial and circumferential. Lastly, this is the reference that we use for this project. So that's all from me and my other group members. Thank you.